Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss generic programming. So this is a syllabus we are going to discuss one by one. First one is the generic and a template. That is the introduction of the template. Next, the function templates. Then class templates. And next, we are going to discuss exception handling mechanism. That is try and catch. Then multi-level exceptional and user-defined exceptional. Then we are going to discuss dynamic modeling. That is package diagram, UML component diagram, UML deployment diagram. First we will discuss the template introduction. The template allows writing generic programs that work with any data type. It avoids writing the separate code for different data types like integer, float, character. The template is a keyword used to define the templates. And next one is a type of template. The function template, it is used to create generic function. It works with different data types. And next is the class template. It is used to create the generic class. It can store and process any data type. First, we will start with the function template. The function template works similar to a normal function. In normal function, you need to write separate function for each data type. But in the function template, the single function is enough to work with different data type. If you need to perform the identical operation on two or more types of data, then you can use function overloading. But in the function template, to perform the same task for multiple data type using only one functions. The function template are a better approach because less code is needed and code become easier to maintain. It support code reusability and flexibility. So the syntax template within the tag class T or template within the tag type name then T. We will see the method overloading and function template comparisons. So it's the method overloading. Already you know the method overloading concept, right? We will use different same function name and different parameters. For example, in different data type, we will use different function to handle the each data type. For example, class sample. And then here two different data type we are going to handle, integer data type and then double data type. So here we need to write separate function for to deal with each data type. For example, void, the function name is the parameters is integer x and integer y. Here we are doing the sum of two numbers. Then followed by we are going to write one more functions, that is void add. The parameter is double a and double b. Then we are going to do the sum of the double values. So here the function name is same, the parameters different, and then we are doing the same operations. So here the main functions, creating the object from the class with the help of object, then we are going to invoke the function s1.add the parameters 2, 3. But here the function name is same, right? That cases based on the value we are passed in the function, it will invoke the corresponding function here. So here 2, 3 both are the integer, right? Then it will invoke the first function, then it will do the addition of two values. Finally, they will get the result 5. Then control is come to the main program. Then it will invoke the one more functions s1.add. The input is 2, 2 and 3, 3. So that cases it will invoke the second functions. Then here it will calculate the sum of the values. That is the values belongs to double. Then the finally will get the result 5.5. The same code we are going to reduce the number of line using function template. So here include that is a library. Then here template is a keyword. Within the tag we are going to mention class. T is a generic data type. Again the function name. So first to start with the return type. The return type is generic, that is T. The function name. Then we are going to pass two parameters, A and B. Both are generic type. That's what we are mentioning the prefix T, comma T. So here we are mentioning the formula within the braces. Then finally the result will be written. The main program we are going to invoke the functions add 2 comma 3. So add 2 comma 3 here. So the first value is integer and the second value is integer, right? So then we are passing the value. We are going to invoke the function. That case as the first t is become the integer because the value is integer. The second t is become the integer because the second value also integer. Then it will do the integer operation. Then it will return the result as an integer. So now this t become the integer. Then we will get the result 5. Again the controls come to the main program. Then we are going to invoke the function with the different parameters. For example 2.2 3 comma 3. So that case as the first t become the double, the second t become the double. Then we are getting the input, then it will do the operation, and finally the result is written. The return result is belongs to double. Then this also t is become double. Then finally we'll get the result 5.5. So it means the template, it will reduce the function code size. So here the method overloading, we are using different function for to deal different data type. But here the function template, it will use the same function, then it will deal all the different data type here. This is the way we are going to reduce the number of lines. And one more example. Suppose a function template with two different data type. Suppose we are passing mixing data type. That cases how it will deal. For example, class. So here template, then class T, comma, class U. So now different parameter we are passing, right? So now we are creating two generic data type, class T, comma, class U. Then function name is void multiply, then parameter name, that is T, comma, P, U, comma, P. That is T and U is the generic. Then here we are doing the operation multiplication. So now integer, we are passing the integer value a equal 2, b equal 3. Then float x equal 2.2 and y equal 3.2. So multiply a comma b. A comma b both are the integer, right? So now the t become integer, u become the integer, then it will do the integer operation, then it will print. And controls come to here. X comma y. So both are float, right? So now t become float and u become float, then it will do the float operation, then we will get the result. And control is come to here. A comma x. A is belongs to integer, x is belongs to float. So that case as the first t is become the integer and u is acting as a float. Then it will do the operation. The finally it will return the highest data type, that is a float. Then finally we'll get 4.4. The next concept, class template. The class template allows a class to work with different data types. It is a generic class. It helps to reuse the same code for multiple data types. It reduces the code duplication. It is similar to function template but applied to the classes. The syntax template within the tag class T, class name. So here variable is declared using generic data type. Then function is declared or defined using generic data type. And then how to create the object, class name, data type, then object. We'll see the one example. Template class T, the class number. So here we are declaring the variable. So this variable, the data type is generic. And next one is the constructor. So here we are going to assign the value. The assigned value belongs to generic. So this value is assigned to the class variable. And next one is the one more function, get name, get number. So now the return type is generic. So it will return the number, the class is closed. So here we are creating the object from the class number. So for example, n1 is the object we are creating from the number. At the same time, we are passing the value. When the object is created, automatically the value is passes to the constructor. For example, number 7. And we are creating one more object from the same class name n2 and then passing different values. For example, 7.7. When the object is created, automatically the values is assigned to the class variable. So now different object and then variable name is same, then 7.7. So now n1.getNumber, automatically the function is invoked. So then it will return the result. So now we are using the n1 object, right? Automatically what is the inside the value? 7, that will be print. Then n2.getNumber, then it will go to here, then it will return the number. So we are using n2 object. So inside the n2 object, what is the variable values? 7.7, that will be print here. And then class template with more parameter. So if you are using different parameter, that cases how it will deal, we'll discuss. Template class T1, class T2. The class member, we are declaring two variable, both are belongs to the generic data type T1, T2. And next one is the constructor. We are passing two parameter. The two parameters the generic. We are passing the value. We are assigning the value to the variable. The next one is the operation, that is the multiplication. The return type is generic. So then it will return the multiplication of value here. The class is closed. When the object is created, automatically the value is passes to the constructor. So first one is the integer and second one is the float, right? That is the double. So now T1 is acting as an integer, T1, T2 acting as a double. So now values are assigned here. See, n1 equal to num2 equal 3.2. It belongs to n1 object. Again, we are creating n2 object from the same class name. We are passing different values. For example, 5.1 and 6. The 5.1 is a double. So now the T1 become double, T2 become the integer. So now the value is assigned to the variable in the n2 object. Suppose n1 dot multiplication. So now n1 dot multiplication means number one value. So see here n1, what is the number one value? 2. The number 2 value is 3.2. Both are multiplied, but the return type is integer. So now the result is 6. And next one is n2 dot multiplication. So now that cases n1 number one value 5.1, n2 value is 6, and then both are multiplied. The returned value, that is first value is the double, right? So the return value become the double, then it will return 30.6. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss exception handling. What is the exception? Exception is an abnormal condition or runtime error that occurs during the execution of the program. It indicates the problem that occurs during the program execution. What is the exception handling? It is the mechanism. It is used to handle the runtime error so that the normal flow of the program is not interrupted. It helps to detect the error and managing the error. For example, divide by 0, invalid input, file not found, etc. So without crossing the program. So what are the advantages of the exception handling mechanism? It will prevent the abnormal program termination, separate the error handling code from normal code, and makes debugging easier, improve the program reliability. Next, the features of exception handling in C++. We'll discuss one by one. Resolve exception. It means detecting and handling the runtime error efficiently. Next one is program continuations. It will allow the program to continue executing even after error is occurring. And next, user notification. It notifies the user about the problem in the clear and a meaningful way. Next one is controlled termination. Terminate the program safely when necessary instead of crossing the program. And improve the reliability. It makes the program more robust and fault tolerant. Keyword used. So what are the keywords used here? So here we are used three main keywords in exception handling. Try, throw, catch. Try here a block of code where the exception may occur. And throw means used to throw the exception. And catch, it will deal the exception. And next one is the working principle. The risky code is placed inside the try block. When an error is occurred, it is thrown using throw. The catch block catch and handle the exception. The next one is multiple catch block. The program can have multiple catch block to handle different type of exception. And next one is default catch or catch all. So the block can be used to handle any type of exception. This is one of the common type. And type of exception. So here there are two type of exception. Synchronized exception, asynchronous exception. Synchronous exception means the synchronous exception or error that occur during the execution of specific statement in the program due to incorrect logic or operation. Example, division by 0, array index out of bounds, invalid type of conversion, accessing invalid memory. And next one is asynchronous exception. Asynchronous exception are errors that occur due to the event outside the program control. These exceptions are generated by events such as hardware failure or system interrupt. These exceptions are unpredictable and can occur at any time during the execution. Example for failure, keyboard interrupt, disk failure, and network disconnection. And next we'll discuss try, throw, and catch its role. For example, first we'll start try. Inside the try, we are going to write the code. If any error is occurred, so it will thrown by the throw statement. And then catch, it will receive the error and it will handle. For example, the concept is divide by 0 or divide by values. So for example, we are declaring a variable a comma b. We are getting the input value for the a and b from the user. Then we are going to verify whether whether the b value is 0 or not. The try block. If the b not equal 0, then we will do the operations. If not, then it will throw the b value. Because any value divided by 0, that is also error. So it is thrown by throw statement. So now the catch statement, it will receive the values, then it will show the error message as error division by 0 is not allowed. Next, nested try block. Nested try block means placing try block inside another try block. So the each try block must have its own catch block. It will allow handling different exception at a different level within the same function. For example, outer try block, then inner try block, then followed by the catch statements. For example, the outer try block, it has some messages. The inner try block where we are going to build the code. For example, int a value equal 10, b equals 0, we are verifying the b values. So if b value equals 0, it will throw the message or it will do the operation a divided by b. Suppose the b value equals 0, then it will throw the message division by 0 error. So now the corresponding catch, it will receive the message, then it will show here. For example, division by 0 error. Again, one more throw is there, this outer, then throw 20, then corresponding catch, that is it belongs to integer, right? It will receive, then it will show that the values. And next one is the multiple catch exception. Multiple catch exception is a mechanism where one try block is followed by multiple catch block. It is used to handle different type of exception separately. The single try block can have multiple or many catch blocks. So the each catch handle a specific data type of exception. Sometimes we will use catch all is the default handle for unknown exception. For example, the try block. So here we are passing the values. For example, 10 is passes to A, then B value get from the user dynamically. Then we are verifying the B value. If B value equals 0, it will throw the message. For example, divide by 0. Else the B value less than 0, then it will throw the values. Else it will do the operation. For example, A divided by B. So now suppose the B value equal 0. So automatically the corresponding catch it will receive, then it will display. Suppose the B value is negative, then it will throw the B value. Then the integer catch it will receive, then it will show as negative value not allowed. Suppose it not handled any catch, then automatically the default catch, right? Catch all it will execute, then it will show as unexception occurs. Next, user-defined exception. A user-defined exception is an exception created by the programmer. It is used to handle the custom error that are not covered by built-in exception. What are the advantages? Handle specific application error, improves the readability, make the program robust and modular, support object-oriented error handling. We will see the example. The class name, invalid age, where here we are defining one method. For example, void message. Here we are writing some message. Age must be 18 or above. And the function is closed and the class is closed. So the main program, we are getting the age as an input from the user. The try block, we are going to verify the age. If the age is less than 18, it will throw the invalid age. The automatically the control is come to here in the catch block. The catch block, it will execute the statement, that is e dot message. So now automatically it will invoke the function, then the corresponding message it will display. The age must be 18 or above. Suppose the greater than 18. So now it will, that cases it will show you are eligible for voting. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss dynamic model. So one of the dynamic model is package diagram. So what is a package diagram? The package diagram is a structural UML diagram. It is used to organize and group the related model elements such as classes, use cases, interfaces, and other packages into high-level unit is called packages. The package are depicted as a file folder and it can be used on any one of the UML diagram. What is the purpose of the package diagram? Organize the larger system into manageable module. It shows dependencies between the packages. It improves the system maintainability and scalability. It supports layer and modular system design. And next one is a notation. So some of the notation used in the package diagram. First one is a package. A container that group the related UML elements. It look like some folder. And next one is the dependency. The dashes arrow sign is used to show the dependency among two elements or two packages. So you see that is the dependency line. It makes the relationship between two elements or two packages to show the dependency. And next one is the import. It represents the below package or function or element has been imported from the above package. So see here, this is one of the package Java, and then this is a import. Then the one more package is util.vector. And next one is the access. The element of one package can access and use the public member of another package. So one package is used to access the another package. We will see the one diagram for bank management system. So here the entire functionality we are going to represent as a package. So here the transaction management, it has deposit, withdraw and transfer. And then the deposit, withdraw and transfer, it will access the account management. The account management has loan payment, transaction log and account mapping. And the ATM management. So the ATM management is the one of the package. Here it has cash dispatch, ATM transaction and the transaction log. So now here the transaction log is accessed by transaction log and account mapping of the account management. And next one is the customer management. The customer management is another package. It has the account holder, address and contact information. So the account holder can access the address as well as the account holder can access the contact information. And then here the transaction management can access the cash dispense. Next one is what are the advantage of package diagram. It organizes the larger system, it improves the maintainability and encourages the modular design. It simplifies the system architecture because the entire functions are composed into single folder. For example, all the related functions are composed, then it will show as a single folder view. So it will simplify the system architectures and make the dependencies visible. And next one is package diagram with class diagram. So here the package diagram and class diagram comparisons. So the package diagram high level structure, the class diagram detailed structure. And next one is the package diagram is groups the classes. The class diagram describe the classes and the relationship. And next one is the package diagram focuses on the modules, but the class diagram focus on the object or classes. So the package diagram, it will group all the related classes and use case or functions, everything. It will show as a single folder. So it will simplify the module. So with the help of the module, then we can simplify the architecture of the diagram. So everyone can easily understand the concept. Thank you. Hello everyone. Welcome to this course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss dynamic modeling. Here one of the model UML component diagram. What is the component diagram? The component diagram is a diagram which shows the physical view of the system. The component is an autonomous unit within the system. It is used to model the structure of larger system and to depict the relationship and dependency among the components. What is the purpose? The visualize the high-level structure of the system and show the relationship and the dependency between the components, and represent the implementation detail such as libraries, executable, modules, and database. It supports the system design, maintenance, and deployment planning. Components of component-based diagram. The component represents the modular part of the system that encapsulates the functionality. So the three views there. Rectangle with the component's name. This is a one view. I will show the highlighter here. This is the one view. And next one is the rectangular with the component icon. See the icon. So the rectangle with the icon. And next one is rectangle with the stereotype text and or icon. So here the rectangle with the stereotype text under the icon. So the three different view is there, the component. Next interface. It specifies a set of operations that the component offers or requires, serving as a contract between component and its environment. There are two types of interfaces here. One is a provided interface and next one is a required interface. Provided interface means it represents and the interface that the component provides. The required interface, that is socket, it represents the interface that component requires. See the diagram here is the two component and the two component interface with each other. So here the interface is looking as a lollipop symbol. So here it is the lollipops, right? Here it is the provided interfaces. Then opposite like the off circle. It is a required interface. For example, the ordering system. So there are three components. For example, ordering system is another component, customer repository is another component, and the inventory system is another component. So this all the component here making the relationship using the interfaces. So the interface makes the relationship between the component. For example, order system and the inventory system, then product accessor interface. And next one is the order system and the customer repository. The interface is customer lookup. So this is the way we are going to make the relationship between the component using the interfaces. And next one is the relationship. It depicts the connection and the dependencies between the component and the interfaces. So for example, dependency relationship, that is dashes arrow. It indicates that one component relies on another. For example, persons depend on the books. And next one is the association, that is solid line. It shows more permanent relationship between the component. So the library associated with the books. So here the books is associated with the library. Like that, so we are making the relationship between the component. And next one is the assembly connector. Connects required interface of the component to provide the interface of another. So this is the order is another component, account is another component. So we are going to make the relationship using the assembly connector. Next one is a port. It represents a specific interaction point on the boundary of the component where the interface are provided or required. So see here at the end of the component, so the port is attached. So now the each component, it will communicate through the port only. And next one is the artifact. It represents the physical file or data that are deployed on the nodes. So here the online store is one of the component, then shopping cart jar file and next order jar file. This is the artifact. So now it is associated with the online store. So see the example. So here the ordering system. So there are different type of component are involved. For example, order is one of the component and the customer is another component and the product is another component. So it will group the, these all are related, right? These all are grouping as a one component here. And next one is the account. So another component. So now we are going to make the relationship between the component using the interface through the port. So the each component has the port. So with the help of the port only, it will communicate to the another component. So the interface, it make the relationship between the component. For example, order component make the relationship with the customer which is related with the account. And next one is the product component. It make the relationship between the product component and the order component. Next one is what are the advantages of component diagram. It provides the physical system view and support the modular design. It will divide the complex design into small modular, so everyone can easily understand the concept here, and improve the maintainability. So we can easily maintain. If anything is wrong, we can easily identify the particular module where we can do the recoverable. The next one is facilitate the component reuse. So the component can be reused. Suppose the component is common, that cases we can reuse the component and help to understand the system architecture. So this is the way we can easily understand the system architecture very efficiently. Next one is the component diagram. We are going to compare with the package diagram. So the component diagram and package diagram comparison we'll discuss one by one. So now the component diagram is a physical view. The package diagram is a logical view. So component means everyone can view, right? For example, component of the system, then we can tell, okay, what are the component of the CPU? For example, hard disk, the RAM, and then ports, then everything we can tell, right? That is a physical view. And the package diagram is a logical view. That is logically related or logically grouped into one unit, that is called as package. And next one is the component diagram shows software components. The package diagram shows the group UML elements. And next one is the component diagram focus on implementations. The package diagram focus on the organization. So now component diagram, it will show the physical, that is the implementation, and then package diagram, it focus only the organization, how it is organized. And next one is the component dependencies. The package also dependencies there. So now one package is depend on another package. Similarly, the component is one component is depend on another component. So this is the way we are going to make the relationship between the components or make the relationship between the packages. Thank you, everyone. Welcome to the course on Essential of Object-Oriented Design and Programming. In this presentation, we are going to discuss dynamic modeling. So one of the model, UML deployment diagram. The deployment diagram model the physical architecture of the system by depicting the node, that is the hardware devices, and artifacts, that is software component, and communication path between them. It represents the physical deployment of the hardware and the software component in a system. It shows how the software artifacts are distributed across the hardware node and how this node communicate with each other. Then purpose. It shows the physical arrangement of the hardware and the software. It illustrates how the software components are deployed on the hardware nodes and describe the runtime environment of the system and help the system deployment and network configurations. Next one is the component and notation, the deployment diagram. So first is the component. The component represents a modular and reusable part of the system, typically implemented as a software module, class, or package. It encapsulates its behavior and data, and it can be deployed independently. So see the notation here. This is the component notation node. And next one is the artifact. An artifact represents the physical pieces of the information or the data that is used or produced in the software deployment process. It can include source code file, executable, documents, libraries, configuration file, or any other item. So this see the symbol, this is the artifact. And next one is the interface. It represents a point of the interaction between different component or subsystem. And next one is a node. A node represents the physical or computational resource such as hardware device, server, workstation or computing resources on which the software component can be deployed or executed. So see this is the node symbol. And next one is the communication path. The straight line that represents the communication between two device node, and next dashes line in the deployment diagram represent the relationship or dependency between the element, indicating that one element is related or dependent on another. See the example here, client server system. So here, so client is another node and next is the server is another node. So the server also includes the number of nodes. For example, caching server and server. So this also has some of the node inside the server. So now whenever the client send a request is passed to caching server. The caching server, it will store the recently executed information. So if the information is present the cache server, it will send directly to the client. So the client, it will get the response immediately. Suppose the expected information is not present in the cache server. The cache server, immediately the request is forwarded to the original server. So the original server, it will catch the related information or it will search or get the related information from the database. Then the information is passed to the cache server. So one more copy is maintained in the cache server. The same copy is forwarded to the clients. Suppose the clients again is want to the same copy. So it is available in the cache server. Immediately it will get, then it will execute. So this is the way we are going to reduce the time. So here the entire operation we are going to represent it using the deployment diagram. So this is the some other artifact attached or associated with the cache server, and then here some other artifact it is associated with, that is the servers. For example, admin and next one is log. These all are the associated with the servers. And the next one more example, distributed system. So now all the console, it send a request to the internet. So the internet, it will distribute the information to all the regional server. So now all the regional server, it will get, then it will start the execution. So now this all the regional server, it is connected with the country server. So again the country server which is attached with the login server. This is the way we are going to distribute the information, we are going to execute the content. Next one is the advantage. What are the advantage of deployment diagram? It shows the physical architecture. It helps understand the deployment structures. It is useful for distributed system. And it will identify the communication path and support the infrastructure planning. Next is the comparison between deployment diagram and the component diagram. The deployment diagram is a physical deployment view. Come to the component diagram, it is a physical software structure. And next one is the deployment diagram shows hardware nodes. And the component diagram shows the software component. Already we discussed, right? It will shows the only the components. For example, what are the component of CPU? Then we will tell that is the hardware, right? For example, hard disk and RAM, okay, and then port, then memories. Everything is the component of CPU. The CPU is the node. It is the deployment diagram. So the CPU is the example for deployment diagram, and inside the components, right? These all are represent the component diagram. And next one is deployment diagram, it focus on runtime environment. The component diagram, it will focus on implementations. And next one is the deployment diagram, hardware plus software mapping. But come to the component diagram, that is software module relationships. And next, the comparison of deployment diagram and package diagram. So the deployment diagram, there is a physical architectures. So physically we can view the node. For example, CPU is one other node, and a client is one other node, and a server is one other node. So that is a physical structures. The package diagram is a logical organization. So package diagram already we discussed, right? The grouping all the related component into single unit is called as package. So it look like some folder symbol. And next one is the deployment diagram. It shows the node and the artifact. And next one is the package diagram. It will show the packages and it will show the dependencies. So it will show only the packages. What are the packages there and what are the dependency between the packages. And next one is the deployment diagram. It is the runtime view. And the package diagram is a design view. So here we can see how the node it is executed. So through the deployment diagram, it will show the runtime view. Come to the package diagram, only the design view. For the design purpose, then we can use the package diagram. That is what are the packages that is composed in the package diagram. So this is the way we are going to differentiate the deployment diagram and the package diagram. So the deployment diagram is very useful to develop our environment and software natures. Thank you.